welcome back. Day 2. Anybody want to start us off with questions from that first homework assignment? Yes.
Number 58 and 60, they're similar problems, so I just need help with one of them.
Let's see.
From chapter 1.
Where am I at? 58. This guy?
Yeah.
Ooh, okay. Ooh, yeah, sorry. I'm going to do that a lot this semester because I just love math. This one's neat. Let me kind of zoom in a bit so you guys can see that. If you don't know your book. Well, I'm going to write it up on the board too, so I'm really zooming in for myself. Let's see. Do. Good Lord. Do. Okay, so 58. Four X minus plus 3. Do that. 3. Oh, so much weirdness here. So, let me step up to this problem. I'm going to kind of build our way up to this problem, right? So, side note. Make sure I got to be. I should try to hire a cameraman. Okay, camera person. Help me out. How would you factor this? Don't overthink it. Just how would you factor it?
Take out the lowest common factor.
Yeah, take out, well, the greatest common factor, but the lowest power, right? So how many x's do both of these pieces have? What's the most x's they both have? 2. Squared. I love it, 2. I kind of think of it as the sort of fair tax man. It's like they only take away enough to bankrupt somebody, not to make them owe money on top of that. So like, this guy could give 4 x's, but then what would this guy do? He'll freak out. So I can take out the lower power. So what would be left here? 1, good. X squared. Yes, right? So that's one thing. Yep. Here's another thing. What about if I had this? Yeah, let's do that. I like it.
You can do some grouping.
Yes. Well, not grouping really. It's not really 4 terms. How many terms are up in that thing? How many terms are in this? How many terms are there?
4.
No. 2. Terms are connected by multiplications. This is one term, and they're separated by addition and subtraction. There are 2 terms. That is huge to realize because one of the most basic factoring forms is GCF. You got to know what the terms are to be able to see what they all have, right? So here's 2 terms. Do they both have any numbers that I could take out? The first term has a 4, yes? Does the second term have a number? Well, it does sort of. It's got a 1, but it doesn't really have any. There's nothing I could take out. Do they both have some number of x's I could take out? Does the first guy have any x's?
No.
Nope. He's got 2, he's got none, so I can't take any x's because the one guy's got none to give. Yes? Now let me ask you a really weird question. Do either one of them have any a's?
Yes.
Nope. I don't see any a's up there. And you're all like, you what? Let me ask you this. Does 8 have a 2 in it?
Yes.
Does 9 have a 2 in it?
No.
No. Yes? Do you understand what I mean by that? What do I mean by in it? What am I implying? As a factor, right? 8 has a 2 in it because 2 times 4 is 8. 9 does not have a 2 in it because 2 times no whole number is 9. Is that, you guys with me? So you got to understand what I mean when I say in it. So, but isn't 9 7 plus 2? Yes? I love the answer. You're all like, that I got. But still 9 does not have a 2 in it. So does A plus B have A as a factor? Let me say it more directly. No. I really want that understood. Does 2 go into 9 evenly? Does 2 go into 9 evenly? No. So does A go into A plus B evenly? No. The same way 2 doesn't go into 2 plus 7 evenly. So I really want you to understand, when I say I don't see any A's anywhere, I see A plus B's. How many A plus B's does this guy have? One. How many does this guy have? Two. I love you guys.
It's early.
I understand. You guys all see that, right? So how many A plus B's can I take out then? One. So if I take an A plus B out, do you see how I put it? This is a little thing, but you see how I put it over here, so then when I do this, the result of this goes here and the result of this goes here? Keep me straight. So what's left here if I take the A plus B out? 4. Squared, 11. Some of you guys might realize this goes further, but well, let's do that right now. Let me stop right there. So pretty cool with what I just did? If you distribute, don't you get the same thing? A plus B times 4, bam. A plus B times bam. So you can real quick check to make sure it kind of goes back. There's one more thing I could do to factor this. What form is this in? Four minus x squared. Can you cut each of them in half? Yes, and is it a difference? Yes. Difference of squares. Okay, I like it. So then cut the 4 in half.
2.
Plus minus. Cut the x squared in half. Done. I love it. I love it. Why does this have to be a minus? Why do these have to be opposite signs? So the middle term will cancel because the middle term's not here. So it must have canceled. So if this was a plus, I can't do that shit, right? Because then both signs would have to be the same. There's no way to kill the middle term. Yes, maybe? I know. By the way, there's a lot of death in my math. I'm sorry. Things are dying. Things are killing each other. I'm sorry. It's like Game of Thrones before season 7 because we don't talk about those. Okay. No? You guys are? Okay. So now, I've gotten closer to this. Why is this one even worse? 2 things. They're fractional powers, and even one of them is freaking negative. But let's look at what we've learned, right? From this problem, we learned to look at stuff like this as one thing, A plus. So what do they both have? They have x minus 1s. Some weird-ass number of x minus 1s. The same way these both had some number of A plus B's. What did we learn from this dude? If I have 2 powers in there, which one can I take out? The lower one. Always. So let's put both of those together. So I know I can take out some number of x minus 1s. That's what this guy showed me. They both have some number of x minus 1. So I can take that out. Now it's just a question of how many. Well, which power is lower? Negative 1/4. All right, now here's where things get weird. The first piece is going to be really simple. If I take this out, what's left in the first term? 4x. All right, that was nice. What the shit happens to this guy? So let me ask you this. Why was there a 2 left here? Yes?
Because you took 2 out, so there was 2.
So there were 4, and I subtracted the 2 that I took out.
Right.
How many x minus 1s are we taking out?
Negative 1/4.
Negative 1/4. So there was 3/4 minus the negative 1/4 I took out. So what's 3/4 minus negative 1/4?
1.
Yeah, 3/4 plus 1/4. There's a whole 1 left. So there's a whole 1. Oh, Jeff, there's a 3 there too. A whole 1 of these left. So when we throw fractions into the mix, the basic underlying idea of what we're going to do does not change. It's just the computations that I have to do get worse. So math doesn't give a shit that there's fractions and some of them are negative. It says the smaller power you take out, and you look at these as clumps of things. Yes? So it doesn't give a shit. No, we give a shit. Right? We don't want the negative 1/4 to the 3/4. The math says, okay, smaller power comes out, and when you take something out, you're going to subtract. Now, is there anything left in here I could do?
Distribute.
Yeah. Now let's do it. Can we do this? 4x plus 3x is 7x. Minus 3. I was going to see how long I was going to do that. Just the rest of the class is me going. That is not an easy, like, gimme problem, right? I think you guys would agree with me. But do you see the parts that go into it? And what I really want you to get from this problem is the parts of a problem can look worse and worse. But the underlying math behind what we're supposed to do with it doesn't change. It can't change. Okay, maybe. So is that, who asked me that? I'm sorry. Does that help you for the next one?
Yeah.
Yeah.
So with your example for the second I, you took out 1AB, right?
1a plus b.
So if you're subtracting the 1 from the 2 ABs that are on the other side, why isn't
Oh,
that-
shit and a half. I forgot I made that a square. Damn it. Damn it. No, that's a good catch. Thank you.
I thought it was stupid.
Thank you so much.
Of course.
And that was part of the reason why I made that a 2, and then I forgot that I made that a 2. So you're right. It should be like this. Thank you, thank you. Ugh. I didn't drink enough of my coffee.
It's early.
Now, this is what I love. So have you ever had math teachers like, I don't make mistakes. Blah, blah, blah. I make some freaking mistakes. So let me know if you see something I did. So me, I was kind of trying to get us to do this, and I forgot that I had put an extra one of those. Okay, so it's the same way. If I take one out, there were 2, so of course there's still supposed to be 1 there. You could distribute this, but it's not going to be any like terms then, right? So there's not really any purpose to it. Okay, thank you. So those are a little bit freaky. They're not going to come up very often, but they could definitely come up. Okay. Anything else from that first? I know there were several people that told me they had tried some. Any other questions from? Yes.
62 or 64.
Oh, okay. Let me see. I'm going to keep this over here in case anybody's still looking at that weird shit. All right, let me see. Oh, okay. So I'll tell you what. I'm going to make my own problem like this. I don't want to do too much homework for you guys. Let's see. What do I want to make? Let's do this. Yeah, looks funny. Okay. Hold on. This is going to be neat for me. Hold on. What? All right, look at that. That's yummy. That's creepy, Jeff. I don't care. I'm going to say that sometimes. It's a little creepy when I call it that problem yummy. Too bad. So what the shit? Now, real quick. I desperately want you to realize, when we put variables into expressions, they are still just numbers. So when variables are present in an expression or something that's simplified, they have to act the same as the numbers would in that situation. What do I mean by that? Do you see how this is the same kind of problem here? What do you got, Jeff? Let's do, yeah, sure. These are the same exact kind of problem. Exactly the same kind of problem. Does anyone disagree with me? You're like, well, I'm generally not going to do that. But you see that. You saw a really good example where I can make mistakes. So you never know. What would I do here? I could just multiply these straight across, right? Why is that not the best first step?
Because you're going to end up with giant numbers.
Hmm?
You're going to end up with big numbers.
Big numbers, and the last thing I have to do is reduce it. So why don't I reduce first? Make my number smaller to begin with. So 4 and 40. So let me do this. I'm going to do this a different way than we ever would. 40 is 4 times 10, yes? And what's 27 based off of this? 9 times 3. We would never do that. We don't really need to. But do you see how 9 goes into 27 3 times? 4 goes into 40 10 times? So the answer is 3/10. I like it. Why don't we normally write this step Because we can normally kind of do that in our head. Can I do this shit in my head? Well, I can. Can we all do this shit in my head? No. I made the problem, so hopefully I did it right in my head. We'll see. I'm worried about that one. We'll see. Okay. So what do I do then? We normally don't have to do this step with numbers, but we have to do this step with freaking variable shit. Now, real quick. I really want this to make sense. Could I, cancel an A here?
No,
Why not?
because that's a squared.
So?
Or a plus 4 is a term on its own.
All right. Okay, good. What is division the opposite of? This is a really dumb question. Well, so what's division?
Multiplication.
Multiplication. So can division cancel parts of an addition or subtraction problem? No, it can't. That's beyond its ability. Yes? So if this was 3a squared times y over a, could I cancel an a? Yes, because it's all multiplication, so division can do a job. If it was 3a squared plus y, can I cancel an a? No. And another way to look at it is, what's being divided by a here, for example? Both of these dumb things, right?
The whole term.
So if I do this, how did this guy escape being divided? That's not fair, right? I really want you guys to see that. Because the most common mistake I see on this is people start doing this, and they go 4 goes into 12, and blah, blah, blah. No. Maybe. Some of you guys are out there like, that's what I was going to do, Dad. Okay, so what's the right way to do this? I factor everything. How do I factor the top here? Yeah, top is a nice one. Is that cool?
Mm-hmm.
2 terms, different squares, bam, cut everything in half, plus minus. Love the hell out of those, right? Okay, what about this guy? Oh shit. We talked about this kind of thing yesterday.
So I'm a little bit confused where you got the Y.
Oh, this Y here?
Oh, no.
That's a 4.
Oh, it's a 4. Okay.
Oh, good
My
Lord.
bad.
Yeah, I feel bad for you guys, I'm sorry. It's, yeah, that's,
Sorry.
yeah. This is not me trying to make my writing worse. This is my writing, so good luck. The day that I can't read my own writing is the day I'll retire. I had a teacher that would actually do stuff and say, what'd you write up there? And he's like, does somebody remember what I wrote? You should go now. All right. So how do I do this guy? We talked about this yesterday. I related it to some movie. Maybe? Do you guys remember? You already forgot? You're like, was I here yesterday? Yes?
You do plus minus.
No, sort of.
Yeah, you do.
I do a little dude
Yeah, and then a big dude.
and a big dude. How many, what's this made of?
A.
A times A times A, right? What's 64 made of?
8 times 8.
No, 8 times 8 is 64. We need it in 3 pieces. 4, 4, 4. Yeah. 64 is a neat number because it's a square and a cube.
Mm-hmm.
So, okay. All right, now watch this. This is cool. So I can put, this is a little dude. He's the little dude. So only one of each can go in the little tiny dude. A minus 4. So these two go here. Do you see how I get a cubed? Check, right? And at the end, these two go there. Do you see how I get minus 64?
Mm-hmm.
And of course, the middle dude, who remembers what the middle dude is? He's the cleanup dude. So he's got to be the opposite sign so he can cancel shit. Yes? It's got to be the opposite sign. And then what works? 4a. Whatever the hell that is, times whatever the hell that is. So look at this. Look, it's 1 of each, 2 of each, product in the middle. You can make it a sum. 1 of each, 2 of each, whatever the shit works, right? There's also this. I don't know if you guys have ever seen this. There's a, I don't really like this too much, but I'll show it to you anyway. Same sign, opposite sign, always positive. And the only one thing I like about that is it goes along with my idea of the cleaner. So he's got to use soap. So hey, all right, yay. Okay. Has anyone ever seen that soap thing? All right. Whatever helps. But I really want, see how the top one, there's 2 of each, so there's 1, 1, 1, 1. This one, there's 3 of each, there's 1, 1, 2, 2. And then this middle term just cleans up the extra shit we get. Just kills it, so it's not there, because it's not supposed to be there, right? There's no extra stuff in the middle. Are you guys okay? Okay. Times, what can I do on the top here?
Pull the 3 out.
Pull a 3 out, 11. What's left?
A squared plus 4a
4a,
plus 16.
16. On the bottom, I just got a plus 4. So now you just start. Now this is not a life lesson, but in mathematics, if you got some frustration, you just start killing shit, right? What dies? What can I kill?
Factors.
Yeah, and they gotta be top and bottom because then they're opposite operations, right? So exactly why does this cancel with this? They're common. What's the only operations in this whole thing? Multiplication, division. So that's what breaking shit up does. It makes the division able to do its job because now everything's connected by multiplication. What else dies?
A minus 4.
Die. What else dies?
A squared plus 4.
Die. So what's the answer?
3.
3, good. Don't leave your survivors behind. So real quick. Oh, guys, there's so much shit I could do with you guys, but I want to show you this at least. Can somebody tell me, is there any questions on that, by the way? Can somebody tell me the variable A, what could it be? What could A be? 3, right? A could be 3, yes? It doesn't have to be 3, be careful. This is what this reduces to, but it has nothing to do with what A is. What can A be? Just, what can I make this variable? Any number, almost any number. Any number except
0? No, 4.
what makes the bottom 0.
Okay.
What makes the bottom 0?
Positive 4.
Positive 4 and,
Negative 4.
okay, I really want you guys with me. When I see a variable sit in an expression, it could be any shit it wants to be, except what makes the expression freak out. In this case, it makes it undefined if it's 4 or negative 4. Somebody give me a number that's not 4 or negative 4. 2. Kick ass. All right, now. Stay with me now. If A is 2, what is this number? 2 squared minus 16. Right? If A is 2. Yeah, it's negative 12. Is that cool? If A is 2, what's this?
8.
8 minus 64. Oh shit. 8 minus 64.
56.
Negative.
Negative.
Does everybody understand what I'm doing right now? You don't ever have to do this. Did it have to be 2? Could have been anything except 4, negative 4. Right? If A is 2, what's this? This will be 4 times 3 is 12 plus 24. Is that cool? It's 36 plus 48 is 84. I can make mistakes again, right? You saw it happen, but I think that's right. And then let's do this one really careful. 2 plus 4. Okay, that's right. Now watch what happens. We already know what the answer is going to be. Because we just did this. I want you to understand. This is not easy, right? But what did we just do? We just reduced an infinite number of multiplications of fractions. Because how many different fractions could these be? Infinite. You can make A whatever the shit you want, right? And that's why it's hard. Because we just did. See, if later you're like, what'd you guys do today? Well, this morning I factored an infinite number of fractions, so what about you? Holy shit. Okay, so what happens here? The negatives cancel. I can do this, right? You with me? And 2 and 56 go to 28. And then 28 and 84, I don't know. See, 4 goes into both, right? And what's 21 divided by 7?
3.
Freaking 3. Of course, we already knew the answer was 3, because no matter what I make A, the answer is 3. You guys with me at all? Okay. That's something you guys normally don't get to see. The concrete idea behind this abstract problem. These are just 2 fractions multiplying. We just happen to not know exactly which fractions they are. Okay, maybe. I call this my hopeful Tai Chi. Maybe. All right. Oh, so we got this? Alright. So hopefully that helps you in both of those, right?
Yes.
Okay. Anything else, guys? Now's the day to get it out. Yes?
38.
Oh! So these kind of problems, let me see, I'll make another one like this one. Let's see, is this did we get? Okay. The main mistake I see people make is they start to like FOIL this out. Is this a foiling problem at all? Why not? Because the operation is subtraction, not multiplication, right? So what do you do?
Distribute the sign,
Distribute the
the negative,
right? So these, what's in front of these?
positive.
A 1. So I can actually take these parentheses, I can just distribute the 1, and nothing changes. What's in front of these? -1. That becomes
Minus 4.
-4 squared,
Minus 5.
-5x,
Plus 7.
plus 7. And now it's just like terms, right? So I do this. Find my x squares, find my x's, find my numbers. Right? And then I can just put stuff together. So how many x squares survive? None of them. They're all dead. What about my x's?
2x.
I got 2 x's left. -2 plus 7?
Positive 5.
Bam. Is that cool? So in general, when you have expressions or even equations, the very first thing you look for is distribution. So you can free up everything so it can move around and get put together with other stuff. How you guys doing? You all right? Okay. So that applies to number 38. Same idea. So you would distribute the negative and just put your like terms together. I lock it. By the way, if I explain something and anything still doesn't make sense, then just ask a follow-up question, right? When I explain something, I'm not like, that's it. You can ask a follow-up, it's okay. Yes?
Can you explain one more time how to factor the cubes?
Yeah, sure.
That one's just very confusing to me.
I understand. So we'll do a couple in a row, just to show you. So everybody got this here? If you want it, okay. Is that still going on?
Yeah, it's still going.
Thank you. Sometimes they'll take a union break. Alright, so cubes. And don't forget there's on the Canvas page, there should be a factoring handout sheet, but even that could get a little confusing. So let's try something a little more involved. Let's see. There we go. Yummy. Still creepy, Jack. Too bad. How do you identify this as a cube? So there's 2 terms, and everything's cubed, right? You can cut everything in thirds. Yes? So I know it's a cubes. The very first thing I do, if I realize it's a cubes, is I put a what? Little dude, big dude. I love it. Okay. So put a little dude, big dude. I left a little space because what is this? 8w cubed. What's that 3 of? 2w, 2w, 2w. Is that cool? And what about 27y cubed? 3y, 3y, 3y. Okay. What goes in the little tiny dude? Yeah, one of these.
3y.
Plus one of these. I love it. Because he's a little tiny dude. You can only fit one of those. Okay. So what has to go here? No. Well, sort of, but 4 w squared. What has to go at the end?
9.
And do you see how I do get, if I do this, of course I get 8w cubed, because I took 8w cubed, then I put part here, and I put the other part there, so of course it's 8w cubed. Same thing with here. Of course it's 27y cubed. But why do I need anything else then? Why do I need other shit? Then you just say you got what you need, Jeff. Well, I got more than I needed because I also get 12yw squared. Do I want that? Damn it! And I also get blah, blah, blah. Okay. So to kill those, since it has to kill those, the sign has to be the opposite sign. Makes sense. So if that's a plus, that's a minus. And then what works is this times this. 2w times 3y. What's that? 6wy. Freakadelic.
So the cleaner dude
Yes.
is always the opposite
Whatever's,
sign
yeah,
of
always
the
opposite sign.
First sign.
And then this times this, whatever they are. So one of each, two of each, product in the middle. And then you got the soap thing to remember how to put the signs in there. Okay, maybe. That's everybody's least favorite because it's the one you can sink your teeth into the least. You just have to remember how things get populated. Okay. Is that better?
Mhm.
Okay. Just takes practice to get it in your brain. Yeah. Okay.
Could you possibly go over 42?
I'll think about it. Let's see. Oh, there it is. Okay. Oh, okay. So, real quick example. What would I do with this? For example, I know it's not the same thing, but we'll build up to it. What would I do with this? The instructions were simplify. Say again?
Take that in X.
No. Here, I can't take an X. They both don't have an X. In fact, just to freak you out, I don't see any X's up there. I see no X's.
You distribute.
I see an X minus 2, and I see a 3x plus 5. So I distribute, right? This guy gets a turn, and this guy gets a turn, right? That's the FOIL thing that we don't even need that word for, because it's just, what would you do if you saw this? I should have started here. What's that? What would you do? Distribute. What if you saw this? Distribute. So I see both of those. So I distribute. Right, so I just distribute till I go mad. Yes? And you're like, you're there, man. All right. So what's x times 3x? X times 5. Negative 2 gets a turn now.
Negative 6. Negative 10.
And then you can put these together. Blah, blah, blah. All right, bye. So with this one really shows, so let me make one like it. Yeah, let's make it like this. Let's do b plus 2 minus b squared minus 2b plus 4. Ha. So I made one that will do something specific. So FOIL doesn't do shit for you here. Because there's a first, there's an outer, there's a middle, and there's a last. What? So, but all you do is this b gets a turn. What's b times b squared? b cubed. What's b times negative 2b? Negative 2b squared, yes? What's b times 4? 4b. Holy shit. Now this guy gets a turn. What's 2 times b squared? 2b squared. What's 2 times negative 2b? Minus 4b. And what's 2 times 4? Holy shit. And now you just put your like terms together. And of course, what happens here, what did I construct? This cancels with this cancels with this, so what do you get? b cubed plus 8. So look what I did. 1b, 2 b's, 1, 2, 2 2's. 2 times b, so I constructed that so that you can see all the middle shit cancels, and that's how you handle cubes. Now, I'm not saying everyone like this will cancel, so don't think that, because I could have just made this a 3, and it wouldn't have canceled, right? Okay. So that one, it won't cancel. You'll get a lot of middle stuff. Okay. Is that cool? Okay. Or who asked me that? I'm sorry. I keep looking at you. You did that. Okay. Anything? Yes.
Can we talk about either 14 or 16?
All right. Yeah, they're actually two different kind of things. I want you 14. Let me see. Put you right there. Shit. The camera's here. I gotta remember that. Um, right. 14. So I'm going to do one like 14. Yeah, once I show you this, it's going to be pretty straightforward. M cubed over W squared to the 5th power. What's being raised to the 5th power? All of it, right? So what is M cubed to the 5th power?
And to the
15. Why do I multiply? Because this is 5 groups of 3m's. Isn't that the definition of multiplication? If I have 5 crates and they'll have 3 apples in them, I got 15 apples, right? This is just going to be M15 over W10. So that's all I have to do there. So 14 is kind of nice. Doesn't this look a lot like distribution? Didn't I basically just distribute the 5? So this is what's called power distribution. Okay. So what about, let's see, 16 is a little bit different, but like 16, what's their point with this? Blah, blah, blah. Okay. Sure. 6 over a squared b cubed times a to the 5th b squared over 2, I don't know, 2. Okay. All right. So what do I need to do first? What's funny is it's the same thing you look for all the time. What do we look for in expressions and equations? Distribution, right? Do you see any distribution I need to do?
Distribute the power?
Yes, kick ass. So let's distribute this. So it's 6 over a to the 6th, b to the 3rd. All right, now everything is free to die. I'm sorry, I'll try to tame that down a little. Everything's free to cancel. That's a little better, Jeff. There you go. So like 2 goes into 6. Let's do the easy part first. All right, I got it. How many A's cancel? 5. How many are left? 1. Where? On the bottom. Because that's where more than work. How many B's cancel? 2. How many are left?
1.
Where? At the bottom. So what's the answer here? What's left alive?
3 over AB.
3 over AB, 11. 3 over AB. Bam! That wasn't freaky at all. So apparently power went out. Let's see. Everybody just, hey, that was,
The doors locking was weird.
That was a weird part, yeah.
yeah, okay, all right. Oh, interesting. All right, just hang out for a second, guys. That's not disturbing.
What happened?
Power's out. Out the next door, and next door, let's see, what do we got? Let's do this. Let's see, let me make a call real quick, and then,
Oh, your phone's right there.
yeah, thank you. All right, I recorded this moment.